about to get started with Decarb Debrief All-Stars. I hope that you like my beautiful ensemble that is dedicated to today's program. Trigger warning, there will be baseball puns throughout this presentation today. I have to thank my team here in Minnesota for helping me with a lot of brainstorming on baseball puns, which you will hear ad nauseum. I expect to hear groans and claps. All right, it is 12 o'clock on the dot, so we are going to get started. Welcome everyone to our Decarb Debrief All-Stars game. What we are doing today is this is sort of designed to be a retrospective of the past 11 episodes that we have had of Decarb Debrief. Believe it or not, it has been a whole year of this program and we've had many illustrious guests on the program. It's been an amazing ride. And so what we've done today is invited them back to share one of three things. The first thing could be something we didn't get to during their session because, you know, there's only so much time. The second thing could be a new thing that they discovered since then that they want to comment on. And the third was a fun idea called an aha moment of something that's sort of just registered for you lately that you wanted to share with the group about decarbonization. So super big thanks to the group. I do also want to acknowledge that nearly all of the past guests are represented, but there were two that were called off to their away games, so I couldn't catch them. They were too fast. So they are not represented today, but it does not mean that they are not all stars. So just throwing that out there. All right, so first at bat is a reaction to our very first episode, which was what is decarbonization? So that was back in June or July maybe of 24. And our host was, or my host was me. Our guest was Martha Larson.
Hey Martha, thanks for being a Decarb Debrief All-Star. Welcome back.
Thank you, Wendy. I'm glad we're doing a summary of all the all-stars. Just starting at the beginning with Decarb Debrief, Decarb 101, as we affectionately called it. Big change there is we've had an election. So there have been lots of machinations of people slowing projects, kind of stopping projects. The IRA legislation through the reconciliation, the big beautiful bill that the House of Representatives passed on May 22nd has
that was my birthday. Wow.
Oh, I'm sorry.
I didn't know that. It's okay.
But yeah, they've proposed some faster phase outs for most projects. Now, some of the projects that our teams are involved with, GeoExchange being one technology that we frequently run into, that has been in progress projects are preserved, and those credits for now are preserved. So we're watching which projects are being eliminated or proposed to be eliminated, depending on what happens in the Senate, which projects are having their deadlines shortened or accelerated so that there's not as much time to get projects into Inflation Reduction Act eligibility, and then which are not being affected quite as much. And our friends at the International District Energy Association and other trade organizations are working very hard to preserve tax credits that especially impact in progress and shovel-ready projects, because a lot of them are indeed still hoping to get IRA credit. Blowing in uncertainty, but there's a lot of inertia, 15 plus years of inertia behind the goals. And so I'd say, although we're keeping a finger on the pulse, we're hopeful that especially our higher ed clients will keep their mission statements and their values and their goals in place, which will generate work for RMF.
Thanks to Martha, one of our all-stars, on those comments on the Inflation Reduction Act. If that's something that you want to learn more about, you can go back and watch that full episode. But I just want to comment and say, when politics throw us a curveball, we can handle a change-up. So thanks, Martha, for your comments there. Next up, our next all-star is Kristen McMurray. who was with us for 2 episodes. It was a two-parter. We called it a cliffhanger because there was so much to cover. And what Kristen went over was a lot about the master planning team's process for how they approach a decarbonization project for a plan for a client, for an owner. So that piece was called Approaches to Decarbonization. And what that looked at is we broke it out by one episode, which was about options that could reduce the amount of carbon emissions but still enable steam systems, thermal infrastructure. And then the alternate was something that would go to a low temperature hot water infrastructure. So there were 2 kind of lays of the land of how we can approach that. So let's just dive in. Kristen, it sounds like there might be something new that you've come across since you last presented on all the different technology options for master planning.
It's not really a new technology, just one that I didn't realize had progressed as much as it has, because it was one that when we brought it up with clients, they're usually pretty reluctant to discuss it even, because it's kind of had a bad reputation for a while. But that technology would be fuel cells, which are a pretty cool technology. What they do is they take natural gas and then they don't burn the natural gas. So instead of burning natural gas, the fuel cell actually, instead of having a combustion reaction, it's actually going to do a chemical reaction, which produces a little bit of water and carbon dioxide. So there still is carbon emissions associated with this. You'll see kind of sometimes some literature will claim that it is totally clean and that there is no carbon, and that is not true. But it produces less carbon than when you burn it. And then the other thing that's cool about it is that this chemical reaction also produces heat. So you can set up a heat exchanger in conjunction with that and use that to produce hot water.
Cool.
So it's like a combined heat and power plant that you can use. And so you can produce electricity from this and also heat.
And so for some reason, fuel cell implies to me that there's storage to the electricity. Is that true, or am I misinterpreting that?
No, but like one thing that I've been thinking about is potentially combining the usage of that with electrical storage, but I think that's kind of probably not necessarily something that like a college might do. It'd be more so what the utility company may do. Whenever it's come up before, the clients aren't very interested in it, but it's starting to be a little bit, because things have progressed. Same way that air source heat pumps have gotten a lot better over the years. Fuel cells have also been progressing, and they're more reliable and more effective than they used to be.
Are there any barriers of like the kinds of equipment that would need to be installed or things like that? Because I'm comparing it a little bit to something like carbon capture, which is a lot of first costs to set up all the equipment or something like that. Are
Like
there
a big field that
Okay,
you're not putting it underground. It's gonna take up your field.
interesting. Okay.
So like the ones that we saw, they look like a bunch of refrigerators, kind of.
And so like it's a field full of refrigerators almost, is what you're saying? Yeah.
Yeah, that's visually what it would look like.
Yeah.
And as you know, colleges, a lot of times, they're very concerned about the appearance of mechanical equipment on campus. And I'm sure that will be a factor.
Yeah.
But it's something that I want to start modeling a little bit more than I have in the past. Like we've done the models for them, but being able to do it with a higher efficiency than I previously was using it might be a game changer.
I didn't even have to tell her to do that pun, a game changer. Maybe that's what we might see with fuel cell. I want to thank Kristen for sharing that new insights on that technology. I wasn't aware of it before our conversation, so it was super cool to learn about that and that new opportunity. And that's going back to what I was saying at the start of the program today. Of anybody that thinks they're a 10 out of 10 on knowledge of decarb is is not likely to be so, because things are always changing. Something that was true of a specific piece of equipment a few years ago might not be true today. So we've got a wonderful team of people that is watching what's new, what's the latest, what's coming out, how our manufacturers innovating how they are using these equipment ideas. So I will end Kristen's section by saying fuel cell could be a decarb home run for our clients. All right, next up, let's move on to harkening back to episode 4. And so what that was a case study of Carleton College. Carleton College is right across the way here. Our Minnesota office is in Northfield, Minnesota. And that's where our leader, our sustainability director, Martha Larson, came from before coming to RMF, as well as Alex Scherf from our team here in Minnesota. And Carleton happens to have an amazing decarb system on their campus. They have a geo-exchange system. And we also had as a guest Mitch Miller, who is a operator and manager on the site at Carleton. So that was a wonderful treat to have that conversation that day. And so what we have for you now is a little bit of follow-up from Martha and Alex about what they've seen since then at Carleton, and a few other things that they've noticed in recent memory. So let's go to that.
How about Carleton College? What do you know is going on there?
I do keep in touch with Carleton College, and they've had some exciting evolutions as well. When we presented a project that wrapped up in 2021, and it was a steam to hot water transition of the whole heating system, and it was an installation of geo-exchange heat pumps as base load with condensing boilers, gas boilers for peaks and backup. And that's a recipe that we're seeing explored and implemented on many campuses, many district energy systems. Carleton is now moving on to I would call it 2.0, phase 2.0. So they are looking for more ways to recover heat. And with a recent residential village project, they installed a smaller heat pump that exchanges heat with their domestic water pipe from the well to the water tower. So they have running water. It's fairly steady temperature because it's coming from deep underground. And so they're sort of looking for even the next generation of more creative ways to recover and exchange heat, recover and get rid of heat, depending on the season. And they also recently completed a net zero energy housing project. So it's their first project that actually is slowing and reducing the growth of demand, as well as decarbonizing supply.
And we got to see that walkthrough in episode 10, I think, of
That's
that
right.
in construction. So go team. Yeah.
Yeah, that was a passive house construction of townhomes, 2 different developments. Yeah, that Decarb Debrief goes over it very nicely. So you can see what it takes to build a net zero energy housing development.
Well, Alex, thank you for being an all-star and being back with us again. We are hearkening back to the days of yore when you were on talking about your work at Carleton College.
Yeah, thanks, Wendy. And thanks for putting this together. It's fun to see everyone's all-star moments and reflect back. We often don't get to do a lot of reflecting. It's just on to the next project. So this is really fun opportunity for us to do that. I think what I'll share about is something I'm learning on a new project, actually, that's carrying forward part of my theme from Carleton and the Carleton project. My role during Carleton was during the construction phase to be doing outreach so people knew what was happening. So the planning had already happened, the project had already been approved, and now it was you have freshmen walking campus and confused why they're getting woken up at 7 a.m. because of drilling. And so that's a different type of outreach, but the one that I think was reflective to me today, actually, as I sat at the University of Minnesota's Energy and Utility Master Plan project, was someone brought up, when is leadership going to hear about this? And they need to know why we are making these decisions instead of just a paper memo. And it's before the official what did they say? They said before the official recommendation gets plopped on their desk. And so I thought that was also a unique take to outreach, that sometimes we're just so focused on the solution or engineering the project that we might forget to come up for air and say, who else needs to see this? And so that was a important lesson I learned today as we go through the master planning process for the University of Minnesota. But then any other project that we do is to, pause during a midpoint throughout the project. And we happen to be approaching one for the University of Minnesota to say, who else should see this and where should we make a pivot or have this conversation and get in front of it so that people are feel like there's some ownership and they're bringing it to the table instead of just putting their stamp of approval on it at the end. So those different types of outreach are something that I thought was really insightful. I just had today.
I love that. I think that there's a phrase I like to use of greasing the wheels. Like how are we preparing people to hear our final recommendation? And if we're not pulling them in before one full day where we're talking about what the problem is, what the methodology was for solving it, and what the solution is, that's all a lot of information. And so even what we were talking about today was we could just talk about the problem. Like, here's what we're up against here. We've got carbon goals. We have a system that needs maintaining. We have limited resources. So we have a lot of different things that are making the problem more and more complex. And so it's not going to just be, well, we switch out A with B. It's going to be a lot of nuance and a lot of learning. So
definitely. And it's important to grow your advocate pool so that when you do end up passing or approving a project and construction starts and it impacts students' lives or faculty and staff's lives in their day-to-day, then you have more advocates in your corner to say, no, we're doing the right thing and here's why. So I think having them on board as soon as possible with that buy-in and understanding, it really helps the project overall successfully.
Love it. Well, thanks as always for being an all-star, Alex. Appreciate all your work, and I get to work with you every day, so it's awesome. I'll see you around.
Sounds good. Thanks, Wendy. Take care.
I have an excellent pun about this one. I think Alex would like it if we loaded our bases as a strategy so that we hit, what is that, a triple header? Or I don't know. I might be messing that one up. Someone, thank you, Alex. Oh, thank you, Juan. Thank you, everyone, for lifting me up there. Okay, but I do love Alex's message about the fact that we have to really preface things, about how we have to bring people along and not just drop that report on their desk and say, here you go, that we do need to grease the wheels or load the bases so that people know what's coming and understand the complexities of the problems that we're solving. So thanks to the team on that. All right, next up, we will be revisiting our episode 5, which was going over some strategies for how we modify buildings that need to be converted to low temperature hot water. And so my guest on that episode was Amy Gossard, who did a wonderful job sharing how she has built an amazing process for kind of grouping like buildings with similar equipment together and what the conversions necessary would be to get them to a low temperature hot water operation. So that was awesome. And I think another piece of that was the fact that she talked a little bit about building envelopes and how there's some important dialogue that happens around that, but I won't spoil that. So I will turn it over to Amy to share a little bit more about some thoughts after the fact.
Thanks for coming back, and thanks for being an all-star for Decarb Debrief.
What I wanted to talk more about and elaborate further was the building envelope studies. So far, all of these large campus, 50-odd buildings always have some sort of envelope component. And we saw with my original nice math display that it takes upward of 200 years to get a payback by just tackling the envelope. And even when you look at windows, which is traditionally the biggest point of leakage, it only has a good payback if they're single pane windows, and in general, that's very rare. It feels like when we're looking at all of these buildings individually, that campuses, clients, anyone looking at them can get hung up on, oh, this building has a leak. And it's not necessarily that the building is leaking. Like if you feel a draft, it's not necessarily a leak. That generally has to do with the zoning of the building and the way that the air handlers are situated. And not all of that is something that you can predict what's going to happen, because you don't always know how furniture's in a space, anything that can create and disrupt airflow. So what we perceive as leaks when we're sitting like in an office and it's like, oh, I just felt a cold chill, it's not usually coming from outside. Heat loss usually happens at the equipment, because when you're transferring one type of heat to another type of heat, even if it's higher temp water to lower temp water, you lose that MBH. And that's honestly where most of that loss comes from. It's not from the envelope. And we have fun, cute ways that I showed some of them before to show people that, but it's one of those learning situations that I think we should all be cognizant of, because first thing we think of is, this is an old house, it's going to have leaks in it. And that's not exactly what's going on when it comes to larger buildings. What the surface area around the outside is not as much as what's happening inside.
Great point. All right, next up is the idea of something new that you've learned recently on a project that you didn't get to maybe in the past that you wanted to share.
More along the lines of an epiphany than learning is when we have a geofields on these large projects, we usually look at what Kristen showed us, which has the entire system that's connected. We have all the buildings connected in a central plan, and that's what we're tackling with it. I've run into campuses that instead of using bore fields or geo exchange for their whole campus, because the heating and cooling loads don't match. And if they don't match, it's not a good system. Some colleges want it anyway because it's the grants, it's what students want, or it's what, the board wants. They don't necessarily know what it is or what it entails. But if you don't have the balance of heating and cooling, it doesn't hit that COP that makes it actually a good decarbonization option. And that's one of the big things we run into here all the time. And like, we'll design the system if they really, really want it, but it's rarely what we recommend. What I found to counteract that is, instead of looking at the whole system 50-odd building level, to look at it at the individual building level, because a lot of the campuses that I've seen have 3 times the amount of heating than they do cooling, but they have substantial cooling in arts buildings, museums, labs, and libraries. So what I've seen is having individual large buildings have their own geosystem, that they're still connected to the central system, so they're able to work in tandem with everything else. But they have, because that building has equal heating and cooling, they have a smaller geosystem that they're able to use that keeps that COP high. The geosystem's able to do what it needs to do. It's smaller, so it's easier to maintain. It's cheaper, it fits in better spots, and you can do it to a couple buildings that are still connected to the system. They're just not always pulling from the system. They don't need to. And it's just in my opinion, a better way to handle the geo exchange systems on campuses that they're never going to have a balance. And even if they do, that balance is going to shift because the weather outside is changing. And then they'll have too many boreholes or not enough boreholes. But when you're working on it at an individual building level, if there is a shift, it's still connected to the central system. The geofield is still able to work at its correct capacity. And if you need to add 1 or 2 boreholes, it's not the end of the world versus
Yeah, it's
needing.
less of a scale issue. Yeah, I like that.
And it's cheaper. You still get the buzzword, you still get the grant, and it's working better.
Well, I really appreciate you sharing your aha moment with us all. I would love it, and think that's something that we should all think about when our clients are asking for this, because it's the cool thing on the street. So
Yeah.
Thanks again for being an all-star, Amy, and we'll see you for the next one, whenever that is. Thanks.
Yes, thanks for letting me record this because
Yeah.
I'm in the field right now.
All right, thanks to Amy for dropping some knowledge on us. I really loved the points that she was making there. And I think she would agree with me when I say, keep your eye on the ball for the true culprit of building inefficiency. Maybe not the envelope. So anyway, thanks again, Amy, for those great points and sharing your aha moments with us on geo-exchange and the sizing of systems and load balance. That is super important. So I'm glad that that was able to be highlighted. Next up, we are going to hear from Miles Marchink, who was our guest for 2 episodes as well. So I don't know, I think that he might be vying for MVP with Kristen McMurray, who did 2 episodes. Well, actually, Martha did 2 also. So y'all are going to have some sort of all-stars game and solve this one. But at any rate, Miles joined us for 2 different sessions where, number 1, he talked about energy modeling and the kind of work that he has been doing for with IESVE models for UVM, and what kind of story that those data analyses can share. He also shared with us about ASHRAE level 2 audits that were complete as part of the Mikabika infrastructure project for the airport that he was helping with, and that involved a lot of data on the different building audits that happened. And so what we're going to do is revisit with Miles those sessions and hear things that he's been thinking about since that time. So I will get that going.
Once we concluded the Massport project, the client started to say, okay, how are we going to take this data and turn it into actual projects? And what we found as a limitation to the ASHRAE audits is we did 5 EEMs for a building. And of course, when you actually go to do a building renovation, everybody else has a different idea of what that renovation should be. It's not just, oh, go replace your air handlers with new heat pump air handlers. It's, well, if we're working there, maybe we should do some roof work. Maybe we need to redo the layout for some reason. And so the owner right now is getting a lot of questions from the consultants, which are not RMF. And I'm not super entrenched in what's going on because the project's concluded, but what we're hearing is that basically they're trying to piecemeal things together, and there's no understanding of the financial impacts of doing half of an EEM or combining it with another. So I think what we learned is that the audit tool gave a very good roadmap of areas to look into, but as a standalone piece isn't actionable as it sits. We did exactly what we were contracted to do, and that was giving them an ASHRAE level 2 audit. And the audit, it's checking all the boxes, doing all the EEMs, presenting all the data in that concise format. And I think, again, shouldn't overshadow the fact that before they had no idea of what direction they should go in. Do we go, do we build a new building? Do we renovate? Now they have at least something to answer the questions, but it's also raised a lot more questions. If we remember, there was a separate, the MICA condition assessment portion of it, MICA-BICA, which was other consultants going through and documenting condition. A big failing of the overall consultant, HNTB, in my opinion, was that they weren't able to take that existing conditions assessment and have financial data or recommendations on top of that then could help to further guide EEMs of major capital improvements. So, okay, yeah, your equipment's not so great. Well, what does it cost to replace it versus what is this EEM costing? That was kind of an aha moment for us in going to other clients, and instead of trying to peddle ASHRAE audits, saying, okay, well, let's do more of a buildings energy master plan and doing all the same steps, but adding in more financial data so that it's a more informed decision of, okay, yes, you have $1.8 million of failing HVAC equipment, and we say you need $2 million to go put in better and more efficient, and that's going to give you X of savings. That is a lot more appealing because it's giving people more of a pathway for a solution versus the audit, which, while again, valuable information, isn't as actionable as it seems on the surface. It's something too where a project of that size, to come away from it, I think they were expecting just to project concludes and then day one start issuing requests for proposals for design consultants, and there's more steps in between. Now they're trying to regroup and say, okay, we've got this data, how do we use it in some way, which we'll see.
Well, thanks for sharing a great aha moment. And it's great follow-up, and thanks for being an all-star.
Happy to take the title. We'll see if we can keep it up.
I will say we don't really want our clients to strike out when it comes to actionable data and recommendations from our audit. So I'm excited for Miles and his team to be helping people navigate that a lot more. And so I think that idea of more of a buildings related master plan is going to be something that is able to get the client from, we have concluded report, what projects do I start bidding out? So really great observations from Miles. Thanks so much for sharing your insights on that. All right, we're in the home stretch. We have one more guest that we want to hear from today. This would have been episode it would have been 8 or 9. Can't remember right now, but we had Bill and Eric who were talking about UMass Amherst work. And during that presentation, we talked through some of the projects that they had planned and implemented on that campus. And we have a follow-up from Bill to share a little bit more about some things that he's been thinking about lately with that project. So let's go to Bill.
Presentation on UMass Amherst, we talked a little bit, I think, about a follow-on project that we pursued and didn't get. So maybe that's why we didn't talk about it so much, which they call the North Energy Exchange Center. We kind of came up with the concept for it with the university, and it was, instead of converting the whole campus, to just pick these 2 buildings that were already already designed for low temperature hot water, and we're going to have standalone bore fields, and instead put a combined bore field a little bit north of the central plant, put these heat recovery chillers, small ones, just sized for these 2 buildings, in an existing chiller plant, and are running hot water lines out to these two new buildings that'll use that low temperature hot water. And it's really a good application and should work very well, be a good test bed for them. It's well underway. It'll be operating by the end of this year now. Because you've got this unlimited resource of the chilled water system. It's 87, 60 hours they need chilled water, on that campus. And so when they need the heating for these two little buildings that they're adding, they can always dump the chilled water into the overall campus chilled water system. So for those two plants, those two buildings, they're going to run very efficiently, very high load factor, very high utilization for these heat recovery chillers, and probably are not going to have a lot of problems with buffering volumes, turning on and off and part load operation, because they have all the freedom of this wide open chilled water heat sink to play against. So it's a good application. And so that's at UMass Amherst. In the another study that we just wrapped up for the Logan Airport, Massport is the owner of Logan Airport. Massport's our client. Same thing. They wanted us to do a study like all of our clients and convert everything to zero carbon emissions day one. And instead of doing a huge heat recovery chiller plant using air source, using Boston Harbor, whatever, using the ground, we're now going to look at a small ground source system for a new terminal that they're doing there. And then we're also going to look at just dedicated heat recovery chillers that you can put in a couple of these terminals. Maybe ignore the older terminals that are going to be decommissioned in 10 years, but the new terminal E, big red spaceship they built out there, that's all designed
seen
for
that.
140-degree water now. They were smart. When they started their design 10 years ago, they designed for 140-degree water, even though they had 200. And they can just plop, or we're going to look at it, but hopefully they can just plop a couple of heat recovery chillers in Terminal E and use that 140-degree water year round, whenever they need it. And whatever chilled water they produce will be able to be dumped into the overall campus chilled water system and work the same way. So I guess that's what I'm most excited about now, is the potential for these apart capacity heat recovery system. It really works well and avoids a lot of problems that all these systems, I think, are seeing as they start up. It's really hard to get 100% emission reductions, but if you just pick off a few here and there, 10% here and there, it can work pretty well as we transition. Pick the easy fruit first.
Thanks, Bill, for sharing his thoughts on ways to break up the work. So I would say that bunting is sometimes a solid strategy. Not everybody has it to hit a home run every time. So if we're chipping away, if we are able to move some players around the field, we are still moving the needle when it comes to decarbonization. So I loved hearing Bill's comments, and then also the fact that we have multiple players in the field who are noticing similar things. So Amy's comments were similar to what Bill's noticing. So it's really great to see that happening across the team. So that is what I have for you today in terms of sharing some nuggets of wisdom from throughout the team. But I have a couple of things that I'd like to do as we slide into home for today. But first of all, I do welcome you. If you have any questions, you can put them in the chat and we can continue the conversation. But as folks are thinking of questions or things that they want to add comment-wise, I would like to share with you something that that our team received from a co-op intern about their experience with Decarb Debrief. I will let her words speak for her. So I'm just going to read this to you. These seminars have been such an awesome perspective shift for sustainability to me. Before I started working here, a lot of the sustainable call to actions were revolved around minimizing consumption and pollution as an individual. It has been so cool learning about what active steps we can take from a design development and construction perspective to make a huge impact on sustainable development. It felt like I was going from a pretty dreary and restrictive view on sustainability to a whole world of innovation and possibility, which has been really encouraging as an environmental engineering major. I gave a 5-minute presentation on what I learned from Decarb Debrief in my environmental politics class, and I truly feel I shared something heartening that many of my peers hadn't heard of before. I hope it encourages you and everyone who has presented to know how impactful this has been. So this made my day, but also I want to impress that these sessions are important for everyone, but I think for our co-op interns, they're really important. So if there's anything that you can do as a thank you for all of these sessions that we've put together to share, I think it would be to recommend it to any intern that you're working with so that they become aware of some of these new topics, or a new employee that is starting. But just be sure that these can live on and these can be helpful resources to people, because a lot of thought and effort was put in by a bunch of all-stars from RMS team to help move the needle on our decarbonization programs. Thanks everyone for joining, and make it a great day. Take care.